Welcome to EDU World Space.
In this question, we have a non-uniformly charged slab, and then we want to find the electric field everywhere. Okay, and at the same time also explain why the electric field for the charged slab at x equals to 0 would be 0. Okay, so this is the charged slab, y x, okay, from minus d to d. Okay, yeah, so this is a infinite charge slab, but it has a non-uniform charge density. So in this case, the rho is rho naught x over d square. Okay, x over d and the whole thing square. Okay, so we want to first part A, explain why the E field at x equals to 0 is 0. Okay. Okay, so first thing we recognize that the charge density is symmetrical about the x equals to 0 plane. Okay, so we have E x equals to E minus x, okay, in magnitude. Okay, we also recognize that for x greater than 0, the E is pointing in the positive I hat direction. Okay, and for x negative, E is pointing negative I hat direction. Okay, so at x equals to 0, okay, we have E0 equals to E like minus 0, something like this, right? And at the same time, they need to be in opposite direction. Okay, so the only possible solution is E 0 equals to 0. Okay, yeah, so being symmetrical is one thing, and also they point in opposite directions. Okay, so that shows that they need to be at x equals to 0, the E must be 0. Okay, and then in part B we need to find the electric field everywhere. Okay, so first we find the electric field inside the slab. Okay, so the region is between minus d less than, it's between minus d to d. Okay, but the Gaussian surface, we are going to choose Gaussian surface that is okay, we are just going to choose Gaussian surface that includes the x equals to 0 line, and like this. So when it's inside the slab, it's going to be like this. Yeah, it includes the x equals to 0 line, and at some point x away from the at x from distance away from the x equals to 0 plane. Okay, and then I'll be using Gauss's law. Okay, which says that the surface integral of E dot dA, okay, is equal to charge enclosed divided by epsilon naught. Okay, so the left hand side, E dot dA, is just going to be E times A, because the x equals to 0 side, the E is 0. Okay, so there's only one plane that one surface that has electric flux. Okay, and then we also need to calculate the charge enclosed. Okay, this will be integral rho dV. Okay, and so it will be rho a dx. Okay, from 0 to x. Okay, we'll substitute the function rho naught, and then the a is also a constant, and then x squared over d squared dx from 0 to x. Okay, calculate this, we get rho naught a x cubed divided by 3d squared. Okay, so you put both things side by side. EA equals to 1 over epsilon naught rho naught a x cubed divided by 3d squared. Okay, you can cancel the a, okay, and rearrange. E equals to rho naught x cubed divided by 3 epsilon naught e squared. Okay, so this is the magnitude. If you look at the direction, E is rho naught x cubed divided by 3 epsilon naught e cubed e squared I hat. Okay, so this expression also works. This expression is valid. Expression is valid for x between minus d to 0. Okay, yeah, because we expect the so for negative x, the whole expression will be negative, and this point is which is consistent with the fact that it has to be pointing in the negative I hat direction. Okay, yeah, so this is the E field inside the slab. Okay, this is inside slab. Okay, now we do the case for outside the slab. Okay, so for outside the slab, so this is mod x greater than d. Okay, so draw the situation again. Okay, so this is our slab from minus d to d, and then the Gaussian surface that we are considering. Okay, it will look like this. Okay, and here is the x that we are dealing with. Okay, so using Gauss's law, okay, surface integral of E dA closed, and then we have Q enclosed divided by epsilon naught. Okay, so the left hand side, in this case, it will just be E times A. Okay, yeah, same reason as before, because at x equals to 0, the E field is 0. Okay, so so this side there's no flux. Okay, and then the charge enclosed is integral of rho dV. Okay, so in this case it's only this this part that needs to be integrated. Okay, so the rho has rho naught. Okay, and then we are going to have our x squared over d squared a dx from 0 to d. Okay, you do the integration, you get rho naught a over 3 d. Okay, and then we just equate both sides. Okay, cancel the A, and so the magnitude is rho naught D over 3 epsilon naught. Okay. Alright, so if we consider the directions, then we have to write in this way. Okay, rho naught D 3 epsilon over 3 epsilon naught for x greater than 0. Okay, and negative rho naught D over 3 epsilon naught I hat for x less than 0. Okay, or to be more exact, should be greater than D and smaller than minus D. Okay, so this is the answer for outside the slab. Okay. Right, so that's all for this question.